So 2 is something you may remember from Algebra 1, you may not. Is this relation a function is talking about, does each x value have only one y value? They can't repeat. So if every x value has only one y value and it doesn't repeat, so like the negative ones repeat and have different y values, this would not be a function. If we were to plot all of these on a graph, it wouldn't pass the vertical line test, so that would also tell you it's not. Any others on the short bite? Alright, so a couple of things. As I mentioned earlier, your little grade sheet, the first page is marking period 2. The marking period ends the 27th, so you have a few weeks to get those grades up if need be. The Unit 4 test and the Khan Academy that went along with it were the last grades that I was putting in for marking period 2. So everything we start doing today, moving forward, will be put in marking period 3, and I'll repeat that again as we get closer to the end of the quarter. Yes.
Can you still do the Khan Academies?
Yes. You just have to email me or message me so I can update those grades. Yes, you can still do Khan Academy from Unit 2B, Unit 3, Unit 4, all of those. What else? As you are looking at both grades, the year grade is your marking period 1, marking period 2, and it'll change a little bit. So if your marking period 2 grade is below a 50, it'll get averaged to a 50, so it'll change. Your year grade will change a little bit. But if your year grade is not passing right now, you need to work hard to make sure your marking period 2 grade is good, and work even harder moving forward so that you will pass this class. Because if right now your year grade is not passing, you're going to have to work really hard to pass the next 2 quarters. So keep that in mind. What else? On your course calendar, there's a few things I want you to point out, keep in your mind. There are only going to be 2 sets of Khan Academy quiz dates for this unit, this week and next week. There'll only be 4 Khan Academy quizzes for this unit. This unit will only be 3 objectives, and how we do that depends on how much we get done in a day or not. There will be 2 flex days. One will be more so review day, but can also be used as a flex day, and then the last day is an actual flex day. And then your quiz is the 19th, test is the 23rd, unless you have snow days in between that, or code orange in between that. The last day, I'm taking missing work, retakes, missing tests is the 26th. So the quarter ends the 27th. The last day I'm taking stuff is the 26th. Please do not wait until the 26th, because if you all wait, I will have 120 something of you in here on Thursday, and I'd rather not. So please come see me as soon as possible to get retake stuff done, missing tests done, Khan Academy, turn it in as soon as you can do it. Questions on any of that? All right. As I say for every new unit, if last unit maybe you were on your phone a lot, you were sleeping, you were not paying attention, try to do better this unit. This unit is going to be on variation, how things relate to each other, kind of like proportions, but not. So everyone should have these notes. Bless you. I wasn't sure if it was a sneezer. Oh, also, really quickly, I know we're drawing names on Friday, and I know we voted the Friday before we went on break, and some of you weren't here for that, but I don't remember. Did we say repeats or no repeats? Those of you that were here, because I don't remember. I just didn't write it down. Or we can vote again. So if you would, when we draw names, would rather we repeat anyone who's won, raise your hand. Or rather, no repeats. Raise your hand. No repeats it is. Until everyone's at least one. Alright. I'm going to try and talk my loudest. If you don't understand something I'm saying, just ask and I'll repeat. For a direct variation, it's a specific relationship in which there's a constant ratio between all ordered pairs. There's a specific equation for direct variation, and it's written in the form y equals kx. This will look very similar to our slope-intercept form, where k kind of takes place of m, but not. You can kind of think about it as the same, but not. So we're going to be using this equation a lot. How are you sharpening your pencil? And then we're going to have to find k in a lot of these instances. K you might see as the constant of proportionality, or just constant, interchangeable. When we're finding k, the equation for that is k equals y over x. These two things go together. We could find this from the original. I'm going to show you that. So if I took this original equation and I was solving it for k, I would divide both sides by x, which is how we get the y over x. So just in case you forget where that comes from, it is from the original. When we find our constant k, it needs to be the same for all of our ordered pairs, otherwise it's not the constant, kind of like our slope. So we're going to do that for number 1. Do y over x for each set of ordered pairs. If it's the same for all of them, that is your constant. If it's not, then it's not. So 4 over 1 gives us 4. 8 over 2 is also 4. 12 over 3 is also 4. And 16 over 4 is also 4. So because the k is the same in each of these, we can say our k value is 4. And because we know what our k value is, we can write it in the format of the direct variation equation. Y equals 4x. Questions so far? We're going to do 3, and there's something that happens with 3 that we're going to talk about. So let's do the same thing. Divide them, see if the k is the same. So this would be negative 8 over negative 12, which is 4, 2/3. Negative 4 over negative 6, which is again 2/3. The 0 over 0 is not 2/3, but we're going to talk about that. And then 2 over 3 is 2/3. So in general, because the 0 over 0 is not 2/3, we would say the k is not the same. However, if we're looking back at this equation, if this is supposed to be similar to slope-intercept form, what would our b be here? If it's similar to y equals mx plus b, what would be b? Zero. So because our b would need to be 0, if you see something that is 0, 0, that's okay. It's supposed to go through 0, 0. If it doesn't, it's not a direct variation. So that's like the exception to the rule where that won't have the same k value, but if you plotted all those points, the k value would be the same as you count along. So because that is our k value, then we can write our equation y equals 2/3 x. Questions on that one? So being able to find your k from ordered pairs or table is part of it. Being able to identify equations or graphs that are direct is also part of it. So all of these are Strava. We're not going to do all of them unless you want to see some of them later. So if we're looking at 5 and we're comparing it to the y equals kx, is this a direct variation, number 5? Yes. It's the exact format where k would be 3. What about 6? Would that be a direct variation? Yes. It's also in that format. It just has a fraction or it's negative. That doesn't matter. Your k value would be negative 4 over 5. What about 7? No, because that one doesn't have the x, so that cannot be a direct variation. Right? 8, we would need to solve first. So divide both sides by 2. And you can put this as 5x over 2 or 5 over 2x. So that would be similar to 6. So that would be a yes. And then what about 9? I see yeses, I see no's. Aiden, why yes?
It's a negative 1.
Okay.
And
Okay. So you're saying this part is Roberto, you said no,
I
why?
was looking at 10.
Oh, okay.
But
Okay. Roberto, you said no, why?
Because doesn't look like that.
Okay. What's different?
The X is first.
You said the x is first.
Yeah.
The x, okay. There's a 1 here. So that part's the same. Chris?
So to do that, it has to pass through 0, not 1.
Right. Because that y-intercept is not 0, it's not a direct variation. So anytime you see a b that is not 0, it's not a direct variation. Bless you. Do we have any questions on how to determine if an equation is a direct variation or not? If not, go on to the next page. The same rules we said before apply here. The k has to be constant throughout all of your values, and it has to go through the origin 0, 0. So does 14 do both of those things? Yes. It goes to the origin. The k value is 3 over 2, both ways. So this is a direct variation. What about 15? No. Why not?
Go through 0, 0.
Questions on how we determine if a graph is a direct variation or not? Then there'll be questions where we have to find missing values. So this is where that equation we were using before really comes into play. Because we're going to have to find our k value in order to find our missing value. So let's start with 18. You're going to be given two sets of ordered pairs, one where you're missing something. Disregard the one where you're missing something for now. Focus on the one where you know both the x and the y. If you need to rewrite your equations, y equals kx, k equals y over x. Find k first. Divide your y and your x. Now that you know what your k value is, set up your direct variation equation with your k value in it. Take the other ordered pair, put what you have in there, and solve for the other. So this is x, so y equals -2 times -6, so y equals 12. And then a good check yourself process would be, if I take the 12 and the -6, do I get the k value I started with? Which we do, so that is correct. So really, as long as you remember those two equations, your direct variation, and how you find your k, you can solve all these problems. Questions so far? Let's do 19. Same thing. Start finding your k value first. We have 16 over 4. Set that into your equation. Now we have y and not x. So we have 24 equals 4x. Divide both sides by 4. And then again, if you want to do a little check, so the check part is not necessary, but definitely helpful to make sure you did it correctly. So then we have 24 over 6, which does equal 4, so that works. Questions about that? Then sometimes you'll have, this is saying the same thing, it's just in words now, instead of ordered pairs. So let's try 22. if y is negative 18 when x is 3, so that would be like your ordered pair. That's what we're going to focus on first. Find your k between these two. So divide negative 18 and 3. Put that into your direct variation equation. Look at the rest of the whatever it says. So we need to find x when y is 30, so put 30 in for y. And solve for x. Divide both sides by negative 6. And then I'll still write the check over here. This is negative 5 if you can't see that. So check 30 divided by negative 5 is negative 6. So that works. Questions so far? We'll do one more of these, and then before we move on to word problems, we'll go back and do any other problems we want to see, and then move on to word problems. 22 and 24. Okay, so for 24, we have y equals 10, x equals negative 4. Find your k. This is going to be a subtraction. Put that into your equation. Y equals 5 over 2x. And here we're looking for y when x is 12. So put 12 in for x. Someone multiply that and tell me what you get for y. Sometimes when you get big numbers like this, you think that can't be right. So that's definitely when the check would come in handy, just to double check, is this right? Did I get this right? So negative 30 over 12. Divide both by 6. Yep, that works. So before we move on to the next page, look back at the questions we've done so far on this page, on the last page. Are there any we want to do that we didn't already, that we have questions on? If not, we will. So my page looks a little different because I like cut and paste. So you guys don't have this, but you'll see that when we do inverse. Okay. There are a couple things that tell you that these word problems are going to be direct. One, somewhere it'll say the word direct, so you don't have to like guess that. The words may say very directly, directly proportional. You'll see the word direct somewhere. But also, as you're looking at the situation, one thing will go up and the other will go up, or the other will go, or one thing will go down and the other will go down. So realistic things like the more people that go to a game, the more money the game is going to make. The less people that go to the game, the less money the game is going to make. The more you study, the better you do on a test. The less you study, the less better than you do on the test. Things like that. So what's really helpful is if you start to see that, notice that, but also pick apart what is what. What's nice about these is that whatever comes before the words very directly proportional is always going to be your Y. So the sales at a baseball game, that would be your Y. You will need to know which one is your Y, which one is your X, whether you just put Y and X above it or you write it out. I'm going to do both for these couple that we do just so that you see that, but you don't have to do both, you just have to do one. Which means whatever comes after that would be your X. So the number of people attending would be your X. I'm going to write that off to the side. Sales and number of people. What's also nice about these is that just like the ordered pairs where we're missing a variable or the things that were put into words, these are going to be solved the exact same way. So we don't have to learn a whole new method of solving. So if the sales for a game are 12,000, so we know that's going to be our Y, and there's 800 people that attend, that's our X. We're going to use those two to find our K. So K equals 12,000 over 8. I'm going to do that. Tell me what you get. Okay. Because this is similar to slope, we could think about it like this would be $15 per person. You don't have to write that, but just so you know kind of what that represents. Okay, so now that we know our K, write that into our direct variation equation. Y equals 15x. Then, the hardest part about this is knowing what you're solving for, knowing what you're putting in. So determine how many people attend if the sales for a game are 15,000. What are we looking for? X or Y? X. So put in your Y value and solve for X. How many people attend? 1,000. Make sure that you're labeling these since they are word problems, so 1,000 people. The word problems are also good to check yourself to make sure, because sometimes you get really big numbers or decimals or things like that, depending on what it's asking. So, again, you don't have to do this, it's just good to always double check. 15,000 over 1,000 does equal 15. So that works out. So again, if you know the two equations, you're good. You could do all of this stuff. Do we have any questions on that before we do another? Okay, let's do number 2. So ounces of medication is going to be our Y. Vary directly with the weight of a patient. Again, I'm going to write that off to the side. You don't have to do that, but you can if you want. That's LB for weight. So if a 120-pound adult, that would be our X, requires 3/4 of an ounce of medication, that would be our Y. So let's focus on that part first. The 3/4 we can change from a fraction to a decimal. That way we're not dividing by a fraction. We have 0.75 over 120. Do that. Tell me what you get. I believe so, yeah. So that would be ounces per pound. And then we can use that number, put it in our direct variation equation. Because this is a nice decimal, it stops. We can use the decimal. If it kept repeating, we would just use whatever fraction it is. I forgot X. How many ounces are required for a 200-pound adult? What are we looking for? The Y. So put in 200. Figure out what Y is. 1.25 what? Do we want to see the check, make sure it works? Yes, you can make a pass. I see it now. Do we want to do the check, make sure it works, or are we good? Do you have any questions on that one? Let's jump down to number 5. Same as before, whatever comes first is your Y, so the income is Y. Varies directly as the number of hours worked. If the analyst earns 256, so that would be their income, for working 8 hours. So let's do that part first. Find our K. What is our K value? Say it again. 32. This would be dollars per hour. In this problem, it asks you to find the constant of variation. So that's another form of K. So really, we did that, and we don't have to do anything else. So also make sure that you're paying attention to what it asks for. Don't do more than what it asks for, but don't do less than what it asks for also. Are there any other word problems we'd like to see, go over, do before I let you practice? on this page or on the very last page. And I should say word problems or other problems in general on this page or on any of the last pages. Okay. So what's going to happen is you'll have the rest of the class to practice, and then I'll give you some time to practice next class, and then we'll start the direct variation. So you have, I'm going to move, like I said, one of the Khan Academies to next week, the rates and proportional relationships, but you can work on the constant of proportionality from equations and proportional relationships from graphs, Khan Academies. You can keep practicing in these notes, do either or, and then if you have questions, let me know. But use this time wisely.